Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on writing dynamic SQL in Oracle Plsql, and the topic for this lesson is Best Practices for Dynamic SQL. Some quick reminders. Download all the code that I'll be using in this lesson and my other lessons from toadworld.com/sf, my initials, also known as Plsql Obsession. So anything you see me do in these lessons can generally be found on Plsql Obsession. Just click on the demo zip link and you'll have access to all of my scripts. Click on Training Seminars and Presentations to download PowerPoints that support my various trainings and lessons. In addition, make sure you are comfortable with the material covered in the previous lessons in this series. Make sure you know about what dynamic SQL is, how to execute dynamic DDL, DML, queries, Plsql blocks. You might even check out Dynamic SQL Method 4. This lesson is focused on writing higher quality, more maintainable, easier to debug and fix dynamic SQL. So the best practices I'm going to cover are: first, stored programs, create or replace procedure, package, etc., that have dynamic SQL should be defined as AUTHID current user, unless you want to be in for a big surprise. Consider making your dynamic DDL programs autonomous transactions. Remember, they will commit. Always execute immediate a variable, not a literal string. Avoid concatenation. Bind variable values whenever possible. And take steps to avoid SQL injection vulnerabilities, somebody hijacking your application code. Let's dive in. So first, use AUTHID current user. This best practice applies to stored program units that execute dynamic SQL and also can be called from other schemas. So if you've got all your your data defined in one schema, everybody connects to that schema to run the application. This is not really an issue for you. Very few organizations and applications are structured that way, though. In most cases, you have code, data, etc. sitting in one schema, and users connect to another schema, which of course is the safe way to go, and I'll touch on that under SQL injection. But if you have a situation where other schemas can call your code, and that code has dynamic SQL inside of it, you should consider defining those programs with AUTHID current user, otherwise known as invoker rights. If you don't, the dynamic SQL operation that is executed by those other schemas could have some unintended effects, because the objects in the SQL statements in programs that are not AUTHID current user, that are definer rights, will be resolved using the privileges of the owner and not the invoker. Let's take a look at an example of what can happen. In my drop whatever AuthID script, I'm going to connect to HR and create the drop whatever procedure. You pass in the name, you pass in the type. I'll construct the drop statement and execute it. And I'll start by defining this program as AuthID definer, which is also, by the way, the default. Most of your programs probably don't have an AuthID clause, in which case it's AuthID definer. And what that means is that when somebody else, like Scott, who can execute this program, when somebody else runs this program, it runs with the privileges of the owner of the program, not the person or schema who ran it. Now what I'm going to do is make sure in the HR schema that there's no such table as drop this one. I'm going to drop it if it exists. Then I'm going to connect to Scott. I'm going to create a table called drop this one. And I'm going to call HR's drop whatever program to drop this one. And we'll see what happens. I'll see if it's in fact there when I'm done. Describe drop this one. Then I'll connect to HR. I'm going to redefine my program as AuthID current user. Call drop whatever. And I'll redefine it to be AuthID current user. Does the same thing as before. I'll let Scott run this program. And I'll create a drop this one table under HR. And I'll connect to Scott. I'll call HR drop whatever to drop this one, and then I'll describe it and see if it's still there. Let's grab all this code and run it in SQL Plus. It's easier to see the results here than it is in Toad, actually. Okay. So I create my procedure. I let Scott run it. I drop the table. It doesn't exist. I go to Scott Tiger, and I say create the table, drop this one. Oh, it already has one. So Scott has a drop this one table. HR does not. I call HR drop whatever to drop the table. Wait a minute. It says table or view does not exist. So it's not seeing this table. What it's doing is looking back in the HR schema, and the HR schema does not have a drop this one table. So that's the AUTHID definer. Even though Scott ran the program, Scott ran it under HR's privileges, and so it tried to drop the table in HR. In other words, if HR had that table, it would be gone. Okay. Then I'm going to connect as HR. I'm going to redefine drop whatever as an AUTHID current user program. It does the same thing as before. Then I'll grant execute to Scott. I'll create the table in HR. I'll connect to Scott Tiger. And I'll say drop whatever. Now it says drop the table successfully. But which one did it drop? Notice if I do a describe in Scott, the table drop this one does not exist. So it existed here, and I asked to drop it, and it dropped it in the Scott schema. So what you can see here is that with Dynamic SQL, and particularly with Dynamic SQL, if you don't specify AUTHID current user, if you specify AUTHID definer or go with the default, which is no AUTHID clause, then when another schema runs your code, it's going to apply the operation that it requested to your schema. So even though Scott said, hey, I want to drop my table, what drop whatever tried to do was drop HR's table with this name. So stored programs that contain Dynamic SQL, especially DDL, use AUTHID current user. Use autonomous transactions with Dynamic DDL. When a DDL statement is executed, whether dynamically or statically, Oracle performs an implicit commit. That's the way it works. It's changing the underlying data dictionary. It wants to save those changes before proceeding. You can't stop it from doing the commit, but you can stop the effect of the commit from affecting your entire session because, therefore, in general, when you execute DDL in Plsql, you will also commit any outstanding changes in your session. So a user's been entering some data. They haven't finished yet. They're not committing, but they issue some kind of request that forces a DDL command to execute. By default, their transactions will also be committed. You may not want that. You might. But if you don't, then what you should do is put the autonomous transaction pragma in your stored program to limit the scope of the commit. Let's go back to my drop whatever program. So in my drop whatever, the real one that finds all the programs that match a specified set of wildcards and constructs my drop statement and executes it. This is what I showed you in the Dynamic DDL lesson. Notice it says pragma autonomous transaction. By adding this one statement, even though the commit occurs as soon as I execute one or more DDL statements, in fact each time I execute it'll commit, now the effect of this commit will be limited to this one program. So if there are outstanding changes by the session that called drop whatever, those outstanding changes will not be committed. They will still be waiting for the user to commit. Again, you might want it to commit when you do a DDL statement inside your Plsql code in your production application. Just be clear about making that decision. Execute immediate, a variable, not a literal. Let's face it, it's not hard to learn how to use execute immediate. It's one statement. You've got the into clause, you've got the using clause. It's not a big deal from a syntax standpoint. The tricky part is constructing the often very complicated SQL statement. You might be constructing something from 15 different substrings. You've got to worry about how many single quotes you've got in that string. It can be tough to sort out. So my recommendation is always construct that statement and assign it to a variable first, then execute immediate the variable. That way, if something goes wrong, you can log or view the statement that was being executed and pretty easily identify the mistake you've made. But if you execute immediate the variable, the statement right inside execute immediate, you don't assign it to a variable, that statement is very hard to obtain at runtime. You need access to $$ views and stuff like that. Again, let's take a look at drop whatever for an example. So here's drop whatever doing all this great stuff for me, and suppose that I had a mistake in the way I constructed my SQL statement. Suppose there's a semicolon sitting there where there shouldn't be. I'm going to compile this program. And let's run it. So begin, drop whatever. I want to get rid of, let's see, what do I want to get rid of today? Here's my HR schema. Let's get rid of anything that starts with comp and a table. So my name is comp. The type is table. If I can only type. The type is table. And I want to just check first. So as you can see, my third argument is just checking. Always a good idea when you're doing things like Dynamic DDL. I run my script, and I will try to drop these 3 tables. Okay, so let's try it for real. And let's go back also and do this without assigning a variable, but instead just dropping directly. So let's simplify this whole thing to what it would look like if I was kind of lazy. I just want to construct my statement and take care of it. Execute. So every single time I iterate through my object list, I construct my drop statement right inside my execute immediate, and I execute it. Let's compile this version. Let's try running it now. So now for real, not just checking. I run my code. Oh, and I get an error. Big surprise. This happens a lot with Dynamic SQL. Invalid character. Now, can I see my statement? There's no statement here. It's not inside my error report. So it's very difficult at this point for me to say, I know what the problem is. I must have an additional semicolon or whatever the problem is. I just look at this and I say, oh no, I've got to go back and I've got to try to figure out what the statement was, etc. So don't do this to yourself. Imagine the worst. Imagine that you're going to have a hard time. So let's go back to my original version. Now what I'm going to do is take that complex construction, assign it to a variable, execute immediate the variable. If something goes wrong, I'm going to display the string and then display the error message. So I compile this version. I run it again. Now notice there's no error because I swallowed up all the errors, but I did report my errors and I can look. Oh, I forgot to put in the semicolon, so it worked just fine. All right, there's always more stuff to delete in my HR schema. Let's try that again. Sorry about that. Let's look for everything that starts with DBM SHP. I don't even know what those things are. DBM SHP. So DBM SHP. Now let's go back and introduce a bug into my Dynamic DDL. There we go. Compile. Run my script. Let's clear out the other stuff here. Run my script. And now, notice, I got an error, invalid character, but it shows me what the statement was. And now it's easy to look at that statement and say, oh, of course, I've got that semicolon in the wrong place, or I left off a single quote, or whatever the problem is. But at least you can get it. You can log the problem inside your logging mechanism, or in this case, clearly just displaying the string. But you've got that string. So assign the variable, declare the variable, assign it, and then execute it. This approach is also helpful when you're doing a lot of complex SQL where you've got substitutions of text in your strings. And you might want to create a template. So I might even say up here that I could declare a template drop string and then just substitute in the type and the name, making it a little bit more structured as to how I go about building the string. Bind whenever possible. Now I talked in the Method 2 lesson about binding variables. And basically for every placeholder in your code, like colon and then an identifier, you need to provide a variable to bind into that placeholder. Generally, when you're executing Dynamic SQL, you need to use values of variables in your block. That's very common. So I've got a variable value sitting in my block of code. I execute my dynamic select statement or update statement, and I need to use those variable values in my select statement. You've got two choices for how to do that. One is concatenate the values directly into the dynamic SQL string, so concatenation, and the other is bind the value into the string through a placeholder. And the recommendation is bind whenever possible. There are several benefits. First of all, the resulting code is much easier to use, understand, maintain. Second, you can avoid unnecessary parsing since the SQL statement is not physically changing. You're just changing the bind value. Now, a little point about that. I'm going to demonstrate. You can see that it's the same SQL statement even if you bind in different values. But there are different settings that your DBA can use for cursor sharing that can help you avoid unnecessary parsing even if you concatenate. Finally, you can minimize the chance of injection, which I will cover later in this section. So let's take a look at a variety of issues here. First of all, use concatenation. So here's my update numeric value, which you should have seen before in my other lessons. Pass in my column value, my start date, my end date. Set everybody's value to this column who are hired between the start and end date. Wow, take a look at this code. I don't use any binding. Notice there's no using clause for my execute immediate. And because of that, I have to do a lot of work. So I update the employees. I set the column equal to the value. There I concatenate in the value. By the way, doing an implicit conversion from number to string. Then I need to check where hire date is between low date and high date, start and end. Since I'm concatenating, I have to do all the work myself of converting my string, my date, to a string, putting that inside my where clause. But my where clause, of course, is comparing the dates, so I have to convert the string back to the date. I've got multiple single quotes to make sure I get my strings constructed properly. It's nasty. So that's concatenation. Let's take a look at use binding. Same functionality, much, much simpler. So now I construct my update statement. I can't bind in my column. I can only bind in variable values, not chunks of SQL text. So that's still concatenated. But I set it to my value and I use a placeholder for all the rows where the hire date is between low date and high date, and I just specify the placeholders. And then in my using clause I provide the values. And Oracle does all the translations of the data types. It does native data type matching, of course, so I don't have to convert from a string to a date to a string and so forth. I don't have to string together single quotes 3, 5, 7, depending on how many levels of evaluation I'm performing. It's very simple, very intuitive, much easier to maintain than this. And also, if I bind in different values, my SQL statement stays physically exactly the same. So that Oracle, by default, their default behavior is that they will not reparse the statement. If you pass in different values and your SQL statement is constructed differently, then it's more likely that this program will, or that the Oracle database will parse each update statement that is physically different over and over again. Unnecessary parsing. But the main thing is it's so much simpler to write, so much easier to read, and so much easier to maintain. So bind whenever you possibly can, but you cannot bind the values, or not the values. You cannot bind the names of elements of your SQL statement, like your table, your column name. You can't bind dynamic where clauses. Those have to be concatenated in. Concatenation almost always leads to dangers of SQL injection, which again I'll talk about in just a few minutes. In fact, I'll talk about it right now. SQL injection. So injection means that unintended and often malicious code is inserted into a dynamic SQL statement. SQL injection is only an issue when you've got dynamic SQL. And the biggest risks occur with dynamic PLSQL, since you're writing code on the fly, which can do anything you want. But it's certainly also possible to subvert SQL statements. SQL injection and in general security is a very complex topic, definitely outside the scope of this lesson, and I'm not an expert in it. What I'm going to do is go over the basics, make sure you're aware of the most critical things to avoid doing. But then I recommend if SQL security and SQL injection is a task that you're responsible for, you should check out the experts. And two that I know about are Alexander Kornbrust at Red Database Security, and Pete Finnegan at petefinnegan.com. So check out these two fellows and the work they're doing in Oracle security. So how do you protect yourself from SQL injection? Well, before I go into those details, let's take a look at an example of SQL injection and how it might affect you. So the code injection script. Okay, I've created a program called Process One Row. This program is called from my front-end website. People, without realizing it through their selection, select the table, and they define a where clause that determines which row is going to be processed. So inside my block of code, I've written a piece of dynamic Plsql. So I declare a record of the same type as the table. I select one row from that table for the specified where clause, and then I do some internal processing of that data. And notice when I wrote my code, I tried to be really careful to make sure that the only things you can use in these different places were the things that you're supposed to use. So the table %row type, well, if you put anything else in front of %row type, besides a cursor that isn't defined here, for example, you'll get an error. In my from clause, notice I put the table name right between from and where. Nothing else can fit but one or more tables. And then I put the where clause between where and semicolon. And that's all you can put between a where and a semicolon, right? So I create my program. So my program's created. Then I'm going to do some testing. And one of the big problems that we have with testing our code, and it certainly happens with programs related to SQL injection, is that we test our expected normal usage. We don't try very hard to test things out of the ordinary. We say to ourselves, well, who's going to bother doing that? So normal usage. Specify the employees table, employee ID equals 101, run my code, looks pretty good. If I use a table that doesn't exist, I get an error. Employees bad must be declared. So looks good. Nice program, Stephen. Unfortunately, not everybody is going to be so pleasant about using our application. This goes into production. Our users, the people who are defined as the folks who use the application with no malicious intent, are using it just fine. But then some boy in Kansas at 2 o'clock in the morning says, oh, I discovered your website. I'm going to play around. And what they do is enter employees for the table name, and for the where clause, they write employee ID equals 101 semicolon, and then execute immediate, create table nasty data. Runs this code, presses the submit button. Oops. Insufficient privileges. So here's an example of how you lock down a schema so you can't do things like this. But first, I'm going to let you do it. I'm going to let me do it. So I'm going to connect to sys. And let's just make sure that HR has the schemas that are allowed to do what I want to do, which is be bad. So let's go to HR. Let's alter the table, alter the user. System privileges. I'm going to let this user create a table. Not create any table, that would be a bit much, but create a table and create procedure. And good old Toad lets me do that in a flash. Let's try it again. So I wasn't careful about the way I defined the HR schema. They're connected as HR. They run this code, and it says no problem. And in fact, if I go back to my schema browser, I'll find that there's now a table called nasty data. Nothing in it right now, but the table exists. Wow, I certainly didn't intend that to happen. That's bad enough, but that's just a kid in Kansas. I've heard the young men in the Ukraine, and maybe young women too, are even more creative. It's 4 in the morning in the Ukraine. They've discovered our website. Employees. Employee ID equals semicolon. It's 101 semicolon. Execute immediate. Create a procedure called backdoor that will do anything I want whenever I want it. I run this code, and again, no bug, no error. And if I look at my list of procedures, there's now something there called backdoor. Now, I may not notice that program's there, but now this person can come back and anytime they want to simply execute the backdoor program to perform the commands they want. So those are 2 examples of SQL injection. I didn't think that was possible. It seemed like when I had written my program, I was very careful about making sure that I constructed my dynamic SQL so you could only put a table here. you could only put a where clause here. But what I forgot, what I didn't think about, is that if the person supplying the where clause inserts a semicolon, that will terminate my select statement and then allow them to start executing something else. So depending on the characters you put into these strings, the execution of that statement can have all sorts of wild, unintended effects. This is a very simple, basic example. Again, I would check out those expert websites. The things that they have been able to trick Oracle into doing are just amazing and really, really scary. Even if you're not responsible for security, you should make sure that you understand the basic dangers, what can happen, and the basic steps that you can take to avoid the problem. So let's go over those now. First, restrict privileges tightly on external user schemas. If a user can come from outside into your database, then go to the schema that they're allowed to use and make sure it can't do anything. It can't create a procedure. It can't create a table. And you saw what would happen. Without the privileges, you would get an insufficient privileges error and you couldn't do the things that you're trying to do. So that's the most important step, and that, of course, is primarily a DBA step. Second, use bind variables whenever possible. You can't inject through a value. You can only inject through code. Let's go back to the script. So I created this big block of code, I concatenated everything, and as a result I had some big problems. Okay, we don't want to let that happen anymore. So I'm going to go back into my application and I'm going to look at all the places where process one row is used. And it turns out there are just two basic scenarios. One is I pass the employees table and I do a match for last name and hire date, so a string and a date. And the other scenario is departments, and I look for the name of the department and the date it was incorporated on. So what I'm going to do is say no more of this allowing the users to provide the where clause. That's just ridiculous. What I'm going to do is take their data points, their last name and hire date, their department name, and their incorporation date, and I'm going to pass them as values, and I'm going to construct the where clause myself. So I'm going to take control over that where clause. And in my execute immediate statement, I will now specify that the where clause, it looks actually the same as before. Declare a record based on the row type, concatenate in the where clause. But now the where clause is constructed by me. I control it. And they will not be able to bind through variables. They will only be able to bind through concatenation. So that's the most important thing you can do as a developer. Always bind whenever possible. Never concatenate when it's just a matter of sticking values into your strings, even if you're constructing where clauses. So that's one thing. Next, you can check dynamic text for dangerous text. So you could essentially look at the string that's being passed in and you can ask, does it contain a semicolon? It shouldn't. That's dangerous. Does it contain a select from users, the all users table, which is a common way to access information in your database schema? And the SQL Guard package is a package that I wrote that you might find useful in that regard. It's basically gives you the ability to whitelist your text, to say my text should have these things in it, or blacklist it. It should not have these strings in it. This is a hard thing to use and to do in terms of completely locking down the text that's coming in. The hackers will always find something to pass in to bypass your filters, but at least you can take care of the most obvious things. Next, you can use a new package from Oracle called DBMS Assert that will validate object names and make sure that you have a valid table or view, a valid schema name. Let's take a look. So here what I'm doing is taking the name of the table and I'm asserting that it's a valid SQL object name. And if it's valid, I pass in the table name. If it's valid, it returns the table name, and then I can continue on with it. If it's invalid, then it will raise an error. So let's take a look at a simple example of that. I'm going to check the schema name, make sure it's valid, check the object name, and when I run this code, notice no error. But if I put in a bad schema name, like semicolon select star from all users, I want to hunt around and see what your usernames are in your schema, invalid schema. And if I say, okay, my schema is valid, but my table, I want to select whatever, then it tells me invalid object name. So DBMS Assert offers another layer of protection But I'd just like to note to you that the experts on security also have come up with ways to subvert DBMS assert. So you can use it, but it's not a panacea all by itself. Finally, preface all built-in packages with sys dot. This is one of those best practices that is very hard to argue with, but really hard to get your head around actually doing. So what they're recommending is that instead of saying DBMS assert dot SQL object name, call sys dot DBMS assert dot SQL object name. Why? Because I might call DBMS assert dot SQL object name, but if somebody has previously gone into my schema and hacked into it and injected code, what they might have injected was a new definition of the DBMS assert package. So if I can execute immediate and create a package in your schema, I can create a package that looks just like this one, has the same exact interface. So when you call assert object name, assert simple SQL name, or assert schema name, rather than calling sys's DBMS assert, you might be calling my injected DBMS assert. However, if you include the schema name in front of it, and it's pretty much always sys, there's no way that a hacker can override this call, can redirect it into their own package. So this is the safest way to call any of your built-in packages, including, for example, DBMS output.putline. I know, it's not the sort of thing we want to do, but it can make a big difference in the protection and the security of your code. Now what I'd like to do is sum up in terms of best practices, talking about which approach for dynamic SQL that you should use. As you should be aware by now, there are two approaches: native dynamic SQL, NDS, and DBMS SQL. Here are the reasons to use native dynamic SQL. It's much, much easier. Rather than writing line after line of code, you can write a very small amount of code and it does most of the work for you implicitly. It works with all SQL data types, including user-defined object types, collection types. You can fetch into records and collections of records, which you can't do with DBMS SQL. And in general, performance is faster with native dynamic SQL because it's built right into the language. Reasons to use DBMS SQL: if you're doing method for dynamic SQL, one of the most complicated kinds of dynamic SQL you'll ever need to write, and a fairly rare occurrence. If you need to describe the columns of your cursor, get information out about how many columns you've got, what the data types are, DBMS SQL.describe columns lets you do that. You can't do that with native dynamic SQL, but that's only mostly important for method 4. Prior to 11G, the only way to execute SQL statements larger than 32K is with DBMS SQL, but again, that's no longer the case. And in some cases, you can get better performance by reusing parsed SQL statements with persistent cursor handles. You can open a cursor with DBMS SQL and use the cursor over and over again, and that can give you some better performance than native dynamic SQL, which will allocate a new cursor each time. Well, the bottom line is that native dynamic SQL should be your first choice, and in fact, for most of you, probably DBMS SQL is not something you even knew about before watching these videos. It's an old package. It's only for those outlying, more complex scenarios. So almost everything you're ever going to do with dynamic SQL should and will be done with native dynamic SQL. In other words, execute immediate. But DBMS SQL can come in handy for the really complicated scenarios, and in fact, with Oracle 11G, you can move back and forth between these two approaches. You can start with DBMS SQL and convert the DBMS SQL cursor handle to a cursor variable, and then work with that cursor variable in your static code and vice versa. So, bottom line, stick with native dynamic SQL and you'll almost always have the best solution, and use the best practices in this lesson to make sure that the dynamic SQL that you write is easy to maintain and is secure and works as you'd expect it to work. Conclusions. So, look, first of all, you never want to use dynamic SQL unless you need to. Your code will get more complex, and it will slow down perhaps a little bit. The overhead of dynamic SQL at this point is very small, especially for execute immediate. But because your code gets more complex, you need to take a lot more care to write the code so that it's easy to understand and easy to maintain. The techniques recommended in this lesson should help you achieve the goal: avoid concatenation, bind whenever possible, always execute immediate a string, avoid SQL injection whenever possible, include AUTHID current user, and the autonomous transaction. And then you'll have very nice code that will work as you expect it, unless you've got some really big SQL injection attacks going on and you haven't totally locked it down. And your code should be easier to understand and easier to maintain. I hope this lesson was helpful to you, and good luck in all of your dynamic SQL operations. It's certainly the trickiest part, one of the trickiest parts of the code you'll ever write, and happy PL SQL coding.